This lecture deals with the image on the retina for an ametropic patient, that's to say someone who needs spectacles who's not wearing them, and particularly an astigmatic ametropic patient. Now, this brief example assumes that you have a working knowledge of power crosses, and if you don't, then you definitely want to review the lecture dealing with power crosses, because I'm not going to be able to go over them now. Alrighty. So the idea is this. If we have a patient who, let's say, is a -3 myope, and the patient is wearing spectacles and is looking at a point source distant target, let's say a star up in the sky. This is my pretty little star here. The question is, what is the image that is going to be on that patient's retina? And of course, if it is a point source at distance and the patient is wearing his spectacles, the image on the retina is going to be a point. What if the patient is not wearing his spectacles? Well, a -3 myope is going to have a blur circle on the retina rather than a point. Now, all of this is pretty easy stuff. It becomes more difficult when we deal with astigmatic patients. So let's choose a different script, and let's say that the patient is +5, -2, axis 90. And the question is, when the patient wears his spectacles and looks at a point source distant object like a star, what is the image formed in the patient's retina? Again, when he's wearing his spectacles, the image on the retina is just going to be a point. But when he takes his spectacles off and looks at the star, there are 5 possibilities. A point is obviously not one of them, right? A point is a stigma, and this is an astigmatic optical system. So the rays of light do not, in any point of the system, come down to a point. That's why we say that it's astigmatic. By virtue of sectioning through the conoid of Sturm, there are 5 choices. And the choices are these. The image on the retina could be a blur circle. There's exactly one circle in the cross-section of the conoid of Sturm, and we all know its very nice name is the circle of least confusion. There could be a vertical focal line. There could be a horizontal focal line. And the other 2 objects are both ovals. One is an oval with its long axis vertical, and the other one is an oval with its long axis horizontal. These are the 5 choices. Of course, if we section it over here, we're still going to wind up with an oval with long axis vertical or long axis horizontal here. These are basically just different examples of the same choice. So we've got these 5 things. And the question is, which of those 5 things is going on here when the patient is not wearing spectacles? And we could figure this out using the conoid of Sturm and to see where the retina intersects the conoid in order to come up with one of these 5 things. That's an enormously complicated thing to do, and I promised you simplicity today. Or if I didn't promise it, I certainly meant to. Okay, so here's the concept. Let's say that we have a patient who is a +3 hyperope and is not accommodating, let's take that out of the picture, and is not wearing spectacles and looks at a star. And the star is going to have create an image on the retina of a blur circle. What size? I don't care, some size. Let's compare this with someone who's a -1 myope who takes off his spectacles and looks at the point source target. And what is that patient going to see? He's also going to see a blur circle. Now, I represent to you that the blur circle for the +3 hyperope is going to be larger than the blur circle for the -1 myope. And I say that because 3 is more than 1 in the non-accommodating patient. So arbitrarily, I'm going to say that this patient has got 3 units of blur. And I don't care whether those 3 units are generated by 3 units of hyperopia or 3 units of myopia. I'm just going to call it 3 units of blur. And that this patient here has got 1 unit of blur. Okay? Now our task becomes very simple. We're going to draw out the total power cross for this lens here. And the total power cross is going to look like this. Vertically, it is +5. Horizontally, it is +3. And if you don't know how I generated this total power cross, then you have to watch the lecture on total power crosses, on power crosses, because I'm not going to be able to go over that here. Anyway, vertically, we're going to say that the patient is as if he were a +5 hyperope. And we're going to say vertically, the patient has got 5 units of blur. I'm just going to mark off 5 units here. Horizontally, the patient is as if he were a +3 hyperope and is going to have only 3 units of blur. And all that I do now is connect the dots. And what do I get? I get an oval with its long axis vertically. Really very easy, no drawing out conoids. And this is the image, the oval with its long axis vertically, that this patient will see if he takes off his spectacles and looks at a point source stimulus, a point source light, a star up in the night sky without wearing his spectacles. Let's take something that looks more challenging on paper, but is just as easy. And it is this. This patient is, the refraction is, oh dear, this is not writing. The refraction is +1 -3 axis 135. Okay. So first of all, when we draw out our power cross, it's not going to be vertical, but it's still going to be orthogonal. And this is axis 45. Obviously, the 45 refers to this. And this would then be axis 135, reading across to here. And over along the 135 axis, the patient is going to be +1. And along the 45 axis, the patient is going to be -2. We once more mark out our blur circle, and we say along the 45-degree axis, the patient has got 2 units of blur. Along the 135, the patient's got 1 unit of blur. Do I care that this is generated by +1 and this one by -2? No. I'm only interested in the absolute values. In this case, 2, and in this case, 1. I have my units of blur here, and I connect the dots, and I get an oval. If I were to draw better, it would be an oval, with its long axis along 45. Again, what is normally a very complicated problem turns out to be very simple here. And maybe we'll do just one more problem for completeness sake. Let's say that we have someone with spectacles that are -3 +3 axis 180. Very easy problem. So along 180, the patient is -3. Vertically, the patient is 0. The patient has got 0 units of blur vertically, has got 3 units of blur horizontally. We connect the dots, and what do we get? We find that in this patient, what he sees is the horizontal focal line. Okay, thank you very much.